So I'm Samy. I was not planning to do game dev originally.
Hmm.
I was an electronic engineer, EE. Uh, I was working in trains, in missiles, and this kind of stuff. Then I did a pivot to security, to software security, and so I worked in a small startup. And this startup actually got successful and got acquired by a big group. And at this time, I was working with some ex Infogram. So Infogram, if you don't remember, was a very big French publisher of video games.
Hmm.
They made Asterix games and a lot of that jazz back in the 90s and even before. They own the Atari brand, for example.
Oh, okay.
And so in France, when you work in France, you can find a lot of those people that work in these big companies laying around. And there was one in this startup, and so this guy pushed me actually to go at Ubisoft because he knew he also had ex Infogram colleagues that were working there, and so the networking was in full effect.
Hmm.
So it was a completely random act of chance, basically. I always loved video game, right? And
Hmm.
even my uncle worked in video game at some point, but I never thought it was accessible for me, right?
Yeah. Until you had the connection, and then it's like suddenly the door is like open. How long were you there?
Oh, I stayed 2 years and a half, and it was a very fortunate years for me because, yeah, Ubisoft was perfect for a junior to start
Hmm.
because it was the opportunity to work on big games right off the bat with people with a lot of experience. Uh, and Ubisoft incorporate a lot of junior. Like it's why it's hard to start in video game because a lot of studios want to stay small, and so they only hire senior people, right?
Yeah.
Um, and big publisher like Ubisoft, for example, hire a lot of junior. And so you can get started and get some big names to your resume because it's what matters at the end of the day, right? And so I started working on Assassin's Creed 3, Assassin's Creed 4. I worked a bit on Assassin's Creed Unity.
Oh.
I worked a bit on Just Dance 5. I worked a bit on The Crew,
Oh,
racing
nice.
game, awesome. And my last project was Ghost Recon Wildlands.
Was the
Uh,
crew the first one where you worked on? Was that your first live service game that you'd worked on?
yeah, kinda. I mean, Assassin's Creed was already trying to do to the live route, right?
Hmm.
Every game at Ubisoft at the time was trying to have at least a year or two of live service updates, uh, which was a bit different from before, where you would release and then you would have an add-on, an extension mid 6 months after, right, or 8 months after, and
Hmm.
that was the end. Here, even on Assassin's Creed 3, there was live content,
Hmm.
and so we were already in this era. Uh,
Especially Unity, right? Or is it even before Unity they had the live
yeah,
service?
yeah, 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 yeah. For the 3, I think it was pretty big. For 4, I don't. It's a bit fuzzy. I don't remember.
Yeah.
4 was the launch title of the next gen at the time, so Xbox One and PS4. So it was a big leap versus Xbox 360 and PS3. Um, and that's it. Yeah, yeah. The crew was very different. The crew had the infrastructure of MMORPG, basically,
Yeah.
like with shards and so on. So it was very fun to work on.
That's probably some pretty crazy net code.
Yeah, the best to this day, the best netcode I've seen. Yeah,
Oh, really? What
yeah.
like what stands out about it like versus like other projects? Just like how scalable it is?
So the crew was completely peer to peer,
Uh-huh.
and basically the matchmaking was a geo matchmaking. So the crew basically you are in North America, right? And you
Hmm.
are roaming around, and the matchmaking basically matchmake you based on your position with people around you. Uh, and in a way that so you are not on a server, not
Uh-huh.
everyone is on the same shard, but because they matchmake you with people that are close to you, you have the impression that it's seamless. Everything is seamless.
Right. So you're forming peer-to-peer connections like with players as you move through the world, and you're like dropping some and adding others.
Yeah,
Yeah, that is
yeah,
really cool.
very slick. Yeah, and it's when you do peer-to-peer, right? I think it's the power of peer-to-peer.
Uh-huh.
Uh, it's it's seamless. Like there is no start, there is no end. You join in progress all the time. You remove connection, you add connection. And technically, that's very exciting, right?
That is pretty cool. I was thinking
Yeah,
about something similar. I'm working on a dedicated server game, but I was thinking about something similar for doing the voice chat like that way, where like
yeah,
if
for
you're
sure.
in a
Yeah,
room with somebody, then you do the peer-to-peer with just the people in the room on voice chat. But
yeah,
because that stuff
yeah.
doesn't need to be authoritative, really.
Yeah, sometimes what can be hard in peer-to-peer nowadays it's not really true anymore, but it could be slow to establish connection
Mm.
because you needed to do the nut punch.
Mm-hmm.
Nowadays you can use services like Steam Relay or
Yeah, that's what I did in my last game. It was all the
okay,
Steam API stuff.
yeah, it's very good. It's just good. So you don't need to bother about security or connectivity.
Mm-hmm.
It just works, and you can keep the same kind of algorithm, and you're golden. Yeah.
Yeah, dude, the Steam API is actually really cool. They have so much like supported stuff.
Yeah, yeah, yeah. Now and for free,
And for
so
yeah.
we would complain, right?
Can't complain too much. I was just curious, what has been your experience communicating networking topics to like the gaming community, and yeah, just what's that been like, and like misconceptions you found in like online discourse?
I think what's complicated about networking is that networking is here to serve a game design, and therefore, because it's meant for this, every networking model is different from game to game.
Mm-hmm.
There is no golden standard. Even if you use something like Unreal and the networking stack, you will bend it to serve the design. And so you start to use terminology. You use words, right, like tick rate and so on.
Mm-hmm.
Like, what does that mean? Actually, there is no definition of those things, right? They mean different things for every engine. So what you see is like marketing department starting to weaponize those numbers, right? Because they notice that people are sensitive to those definition, and bigger the numbers, the better, right?
Yes.
For example, I've worked on a game that I will not name, where the design director asked me to make the latency indicator smaller because our latency was higher than Call of Duty, right?
Yeah, that's funny.
But actually, even if you mention something as innocuous as latency, right? There's different definition of latency. Is it the network latency? So the pure ping between two machines? Is it the gameplay latency? So the time you send a command to the server and it comes back simulated to you, right? And those things you add up, like the server frame rate and so on in the computation. And so even in something so simple, you see the definition can change. So it's why it's hard to communicate about networking. It's
Mm-hmm.
because there is no clear understanding, definition, and standardization of the terminology.
Yeah, I saw like the Halo 2 GDC talk where they like even on the same tick rate, they have things that send states at different rates depending on how important they are. And that's pretty standard as well, right? It's like what
No, it depends. Actually, it depends.
it depends.
Variable, yeah, because Unreal Engine does that a lot.
Mm-hmm.
They queue and they reorder by priorities, and then they do traffic shaping, right?
Mm-hmm.
They reorder based on the amount of data they are going to send. But some engine, you need to send the full state every time, and there is no way around it. So yeah, it's really depends of the engine and the technology.
Gotcha. So yeah, okay. Yeah, because I guess that makes it very, very hard to compare like across games in general. Like
Yeah,
I know like a lot of people in Counter-Strike 2 complain that they're still on 64 tick when Valorant's like on 128 tick. But as far as
yeah,
they've shown for the CS2, its netcode works like pretty uniquely for that game.
Yes, they try to, and it's something I've done a lot too. So the problem of Source originally is that you need one client command for one server command.
Mm-hmm.
Meaning if you run at 64 ticks, you are going to process 64 client commands, right?
Mm-hmm.
And so that's a pretty big limitation of like input resolution from the client, because it was not a problem before, but nowadays, like everyone wants to run 300 FPS, even 500 FPS.
Mm-hmm.
And so they want to see the benefit of it, right? Uh, and so as what they did is they tried to decorrelate server frame rate with the amount of inputs they can process. But of course, when you do that, the simulation is not as stable, right? Because you introduce the client FPS variability into your server simulation.
Mm-hmm.
And so you cannot compare apple to apple, right? You cannot compare CSGO and CS2 networking models, certainly.
Mm-hmm.
Yeah. Versus Valorant. Valorant, I assume, is the same model as CSGO, snapshot.
One server tick per client tick.
Mm.
That's actually pretty interesting. So they try to scale up how many times they sample like inputs per second with the player's FPS, and then just make it. That's interesting. That's great. That's actually pretty cool.
Yeah, no, I personally, I think that's the way to go. Uh, I mean, it's debatable for Counter-Strike, in my opinion, because CS:GO networking model, in my opinion, was so perfect, so pure for
Mm-hmm.
the gameplay that it requires.
Which is pretty crazy gameplay for that, because I don't know, that seems like a nightmare for netcode, because the time to kill is so quick. Like you could just
Yeah,
within a few frames you can be dead when you didn't see an enemy.
yeah, completely. Yeah, yeah, yeah.
Does that impact a lot of decisions too for network architectures? Like just is like time to kill, like how fast players
Oh, yeah,
move.
everything. Yeah, of course. That's the main metric, I would say. Like, because usually in networking, you hide stuff in the latency,
Mm-hmm.
right? Either in the client latency or the client simulation, or in the server simulation. Um, and yeah, if you have 1 frame or 2 frame to kill someone versus, I don't know, 2 seconds, it changes everything. Yeah.
Yeah. Now to no go back to the older thing, or the thing we were just talking about. As far as like, so this was something I was confused about in my own implementation. So if you have a client that is going at 60 hertz, for example, and then you have
Mm-hmm.
a server running at 20 hertz, that usually means that the server would have 3 client inputs per tick on
Mm-hmm.
average, assuming there's like no loss, right?
Yep.
Okay, so when the server processes those inputs, does it simulate the game state 3 times with using each input that it expects, or does it or do they do some like averaging out? Or I wasn't really sure. Like I saw some people saying you can average out inputs, but I just feel like that would be a lot of mispredictions.
Yeah, it depends of the game. Honestly,
Mm-hmm.
it's always the same answer. It depends of the game. Personally, I would simulate the three. Yeah.
All three. Okay, cool.
What's funny about that is that most of the time on those three, like, order doesn't matter. Like,
Really?
yeah.
Let me think. That's interesting to think about. Let me. So if you
Eh,
have three, yeah, I guess it wouldn't really matter on unless you're like there's some weird player collision with another player or something.
exactly. It depends of your design. Usually, order doesn't matter of you and
Huh.
the people around you. And so, randomizing order is a technique that you can use to fight latency bias,
Uh huh.
right? Like, you don't simulate the fastest player always in first. So you can do the little tricks like that.
That's
Uh,
cool.
yeah.
I didn't think about that. I might have to try implementing that, because that seems like it would also save on like it would give you a little bit more time if you do experience packet loss to get the packet that you're expecting. Because you could just simulate one of the ones you already have, maybe, and then you like wait for the other one to come
I mean,
in.
you will certainly just drop the old one, but
Okay, yeah.
it depends of your strategy. I mean, because if you run at 20 hertz, it means you have a frame of 50 milliseconds, right?
Mm-hmm.
So you would add 50 milliseconds on top of the late one. That is certainly already late. So at this time, the input you are going to process is certainly very old.
Okay.
I don't know. Like it depends of your game again.
Yeah, just have to try it out and see.
Yeah, for sure.
So now to talk about tick rates more broadly, are they primarily this is probably gonna be another, it depends on the game, but are they primarily like a networking constraint or more of a CPU simulation constraint? I don't know how much like a lower tick rate really saves on any CPU power, but
I
I
mean, instinctively,
it doesn't really.
Of course, because if you run at 40
Uh-huh.
and you run at 20, you save half, right?
Well, don't you have to, if you do like the simulation, don't you have to do like a subtick thing too to do the simulation if the client runs at like a higher hertz?
I mean, you will interpolate certainly between two states,
Okay.
but that's mostly what you do. Yeah.
Okay.
But you do save a lot, and it's diminishing returns, right? Because it's not linear. Like
Uh-huh.
as much as you raise your hertz, uh, you gain less and less, right? Your frame is not right.
So yeah, so 40 hertz versus 20 hertz is not double CPU saving.
Yeah. It's
Okay.
a bit of a shortcut. At this stage, it's still very significant. Like you go from 50 milliseconds to 16 milliseconds, for example, 60 hertz to versus 20. But when you go above that, like the time between frames start to be smaller and smaller.
Yeah.
And what's really important for the comfort of your player is that your server never miss, right? Never overshoot.
What do you mean by overshoot in this context?
It means that if you say, I'm going to run at 20 hertz every 50 milliseconds, if your server takes 51 milliseconds to compute a frame, you are kind of fucked, because the real time doesn't match the game time anymore, right?
Oh yeah, that's true. Damn. Yeah, that, so you better be able to keep to it no matter what tick rate you pick.
Exactly. And so it's how you get slow-mo, for example. Like the
Hmm.
simulation runs slow-mo because it takes more CPU time to simulate real time, right? And so, yeah.
If the client's still running fine, then you're gonna have some funny mispredictions on client side prediction too. Like you'll probably have a bunch of like pushbacks and rubber banding and stuff, right?
It depends how you do it. It depends how you do it
Okay.
because yeah, you are going to receive the snapshots. The server is going to tell you its truth of the time, and so on. So you will certainly see the world around you going very, very slow.
Very slow. That makes sense. Let me see. So how do you decide on this? So I was reading the Tribes Star Siege paper.
Oh yeah,
That's a
yeah,
classic. I'm sure.
classic. Yeah.
So they were very, very at the time worried about their players being able to handle all the player state packages.
Hmm.
Is that still a concern with modern networking, or are you more concerned about the server being able to upload everything?
Hmm. Interesting. Um, I would say, yeah, memory is less of a constraint now,
Uh-huh.
so you can save a lot of stuff. But network bandwidth hasn't much evolved. I have the feeling.
Mm-hmm.
And it's not really, I'm not speaking about North America, right? When you want to be successful nowadays, you want to be successful in the world, you want to be successful in China, in Southeast Asia, in Japan, Taiwan, all those, like particularly Asia is pretty complicated.
Mm-hmm.
But then also Africa, India, all those people that want to play your game. And so you need to be resilient, in my mind, to high latency and
Mm-hmm.
try to still limit your bandwidth a bunch. So it's mostly why I would say I'm very focused on those optimization still, because you want to penetrate those markets.
Mm-hmm.
It's not really for the Europeans or the North Americans that have like high bandwidth and that can. You could have very dumb approach, right? Actually, like a good buddy of mine, Glenn Fiedler, like he has the famous introduction to physics for network programmer, GDC talk. I don't know if you know this one. One of his latest article, he was playing with like kernel level driver, Linux stuff to be able to process a maximum packet and to have very high player count. And his point was bandwidth doesn't matter anymore.
Oh, interesting. That's
yeah. And so you can squeeze as much performance as you want from a server host. And if you manage to do that, to limit, because it's still very costly to send and receive packets, right? Particularly to 1,000 player, for example, on a shard. You are golden. I tend to agree, but also I disagree in the sense of if you want to penetrate,
you still need to have some support for those people on lower connection.
Yeah.
So do you usually have like targets depending on like market research for like, I'd like to have like a player state or players, they only have like 100 kilobytes a second. Is there like everyone under then can download it?
Yeah. So console manufacturers have guideline. Usually historically it went from 64 kilobytes again, then 128, then 192. Now, before they were hard guideline, so you could not ship without respecting the guidelines. Now they are soft, but still there is those consideration. I think, usually I would say today in download it will be 80 kilobytes per second, and in upload like 15 kilobytes per second, something like that.
Okay, in that range of like 80, 50, okay.
And it's already pretty high, right? Yeah.
That makes sense.
Because if you think about it, you have to be careful, right? Because if you have a snapshot model, for example, your client can enter a dev spiral, right? If it's too slow to download your snapshot and he can never recover, the guy is only going to play a slideshow. Like every second is going to display the snapshot he managed to download, and then it's never going real time again. Right?
That's true. I was playing I like to turn on like in the source games you can do like netgraph 1 and stuff. A lot of games have networking debug overlays and you can see how much they bring in, and a lot of them are not like a lot of data. It's like a lot less than you think. Like my Wi-Fi can handle so much. This is
completely. Yeah. But it's a recovery scenario, right? If you miss one of the snapshots, like how much time does it take you to recover from this state? And that's usually what we call a full snapshot, because they are all delta encoded. And so if you run out of the delta compression, you will need to download a full view of the world, like if you were joining, basically. And that is the worst case. So usually you want to prevent that.
So do you intermittently send out like full state packets just to like make sure everyone's still in sync? Like I know Delta, that's probably pretty, is that like common? Because I know most of the time you want to just do like Delta packets, right?
Yep.
But like just in case somebody like desynced a little bit, is like do you like some games send out like occasionally the full world state?
It really depends of the network protocol. Usually you don't want to, because there is no reason to. Like if you have a protocol where the client will hack, like for example, Unreal Engine does it by actor, by object.
Okay.
Right? A snapshot system will do it by snapshot, obviously.
That's the whole world in a snapshot?
Yeah. It's pretty an old school way to do it. And there is no reason, like if you trust your algorithm, there is no reason to send full. Usually you will send full if you change point of view. If you switch from player to player, usually you will need to reset your view of the world, because usually you receive a data snapshot from your perspective, from the time you are in, right? There, it's like like snapshot networking is like a time machine. Usually you have everyone has a different vision of the world, right?
Mm-hmm.
So there is not one reality, there is like X reality based on the number of players. And so if you start to spectate someone, there will be a lot of messaging to do, because if you want to spectate what the player is viewing
Yes.
and not what you are viewing, you need to reset basically your states everywhere
to make sure that you have their state or close to it.
But because otherwise they are going to shoot stuff that are not where you see them, right?
Yeah, it's where they saw them when they shot.
I think it's why, for example, FPS are so interesting to work on and so interesting. It's because it's certainly the hardest visually to achieve, right?
Mm-hmm.
Yeah.
Especially with all the tight reaction time and like when you aim on someone's head that you were on their head.
Yeah. And you want that, right? People are very rightfully, right? They want this experience. They want it to be smooth. They want it to be fast. And that's why they play FPS. TPS, it's very, right? You care less, and so on and so on.
Mm-hmm.
Yeah.
So no, I wanted to talk a little bit about input buffering. So the way that I understand it is that I this is on my own project I was working on, is that the server keeps a buffer of player inputs,
Mm-hmm.
and then when it simulates a tick, it will hold, so it holds them for an amount of time in that buffer to make sure it has them, and then when it
Mm-hmm.
reaches a tick that it wants to use it, then it checks if it has it. If it does, it simulates the input, great, and then if it doesn't, it will redo maybe like the last packet it sent, or it'll do like a zero packet or something like that. It just has like some method to make up for it, right?
It depends.
Just some sort of thing.
Yeah, sometimes you process as the server tick starts. Sometimes you buffer. Yeah, really depends of your game. The client can buffer too, waiting for the server tick, or they decorrelate. Some games decorrelate what source called the update rate. So the number of time you update a command to the server, decorrelated from the client FPS. Sometimes it's one command per frame for the client.
Mm-hmm.
So it really depends how you manage that and how resilient your game is at losing input too, right? For example, there is a famous or like very brute force technique which aim at every command that you send, the client sends, you send it 3 times or something like that,
Mm-hmm.
right? And so a lot of games do that, actually, just very simple brute force, so to be sure that you don't miss anything.
I was doing that even a little bit, maybe too aggressively. I was doing, I have like, so I send every input the player received since it last received a world state.
Sure, yeah, it's
And
valid, yeah.
it was reaching sometimes though I was simulating on like 250 millisecond ping, or not ping,
Mhm.
just one way trip. So a full half second round trip time with like 5% packet loss. That buffer gets really big. So I did limit the buffer or the amount that the player can send as a max.
Yeah, but as you say, like nowadays connection are pretty fast and so on. So if you want to optimize for this real time, doesn't miss a beat experience,
Yeah.
it's definitely something you can do. So
Okay, cool.
yeah.
So there's a number of things that it seems like add to, there's like a variable amount of things for delay on the server thing, like things you can control and stuff like that. Like one of them that is not variable though is there's always going to be ping, right?
Yeah.
That's going to be a part of every, like, input is sent to the server, a world state is received back. There's always going to be the round trip time. Another one
Yes.
is that buffer, isn't it? That's like the buffer will always be, that's
Yeah.
another fixed part, isn't it?
It's why you don't want to buffer usually on an FPS.
Okay.
If you have a deterministic simulation, usually you buffer 2-3 frame maybe,
Mm-hmm.
to avoid rollback or whatever.
So
But
if
yeah,
you're not, you try not to buffer on an FPS to avoid that cost.
oh, for sure, yeah.
Okay.
Yeah.
How do you, like, So do you just really have to hope then that the server will have like every input tick by the time it needs it?
Yeah, yeah, yeah.
Okay. That
And
makes
it
sense.
does, as I say, it doesn't matter. Like ordering doesn't really matter that much if you have a good like compensation algorithm. Like it's really a powerful concept. Like you will rewind states very accurately.
Mm-hmm. Okay, so ordering doesn't matter too much. So the on an FPS model or like a really high pace model, you might want to just like as soon as you get the an input thing, you don't really check if it was before or after the last input you process. You just process it.
Oh yeah, yeah.
Okay, that makes sense. That's kind of cool though. My intuition is that that would lead to like a lot of mispredictions, but if they'd use it in other models, that's pretty cool.
Yeah, it really, yeah. I mean, you have to try for your game, and you will see what happens.
hmm So for some authoritative deterministic models, they have an input they're expecting, right? Or a number. Like the player last time the client sent this tick or this input
Uh,
tick.
Deterministic is way more simple in a sense. The client will have a fixed frame rate too,
hmm
and so you expect one input for all this frame rate for all this, and you cannot do anything about it. Like you expect it.
Okay. And then if they don't have that input that they expect, do you still wait for that input on the next tick after you do like some reconciliation thing?
So there is two schools.
Okay.
There is a GDPO, which is a networking rollback that every fighting game speak about. GDPO will predict your input. Predict is a big word. Basically, they will duplicate your previous input. Like if you were moving forward, there is very high chance you are going to move forward the next frame. Uh, and then when they receive your real input and it's different from what they simulated, they will roll back the state and redo the simulation with the input buffer.
Oh.
Right? And
Uh-huh.
that's very sexy, but that's, I mean, deterministic. I don't know if you ever implemented a deterministic game, but it's really a pain.
That's what I'm
Uh,
working on now, and it's a little
yeah, and
wow.
so and so you imagine you are in a state, you roll back, uh, and then you have to resimulate where you were. So it's very costly CPU wise,
Yeah.
and it doesn't scale based on the amount of player, right? It's going to be exponential in complexity. So for 2 or 4 player, it works, but above that, it's very hard. And otherwise, strategy game that don't usually don't use a rollback. They have a high buffer of latency, and if they see that you are missing input, they will just slow down the game.
Hmm. I was playing Age of Empires 2, and you can notice when somebody's missing some
Yeah,
some sense.
yeah. I remember we were playing Supreme Commander. I don't know if you remember this game.
hmm
Um, on Hamashi at the time. Hamashi was
I've used that
yeah,
for
terrible,
yeah.
terrible software, but whatever. And so because the networking was terrible, yeah, you will slow mo like crazy.
Yeah.
Yeah.
Kind of unavoidable for those types of games though. They're pretty hard to sync, I imagine. Otherwise, unless you're like literally just making sure you always have every input that you expect.
But it's still used pretty widely, right? You play, I don't know, Total War
hmm
series. They are still using they are a peer-to-peer deterministic model. Uh, like every strategy game, every fighting game, mobile game, a lot of mobile game because deterministic, you have very a low bandwidth footprint, right? You cannot really get more optimized than that. Um, yeah.
Wait, so we're talking about deterministic, and most of the networking articles and GDC talks I can talk about are for deterministic games. Are a lot of FPS games like not deterministic for?
Not to this extent. They are kind of deterministic because you're running a simulation
hmm
prediction, as you mentioned before, uh, which is a kind of determinism, but it doesn't rely on the determinism to function.
Mm-hmm.
because you still send full state back to the client, so the client can correct and maybe do a misprediction. But
Oh,
it,
okay. I see. So
it,
in the Age of Empires, for example, that's probably not sending full states and stuff to each other because they're
I
just
know if it
yeah,
runs out of sync, it's going to die.
it's gonna die.
Yeah,
Gotcha. So in a deterministic one, you live and die by determinism, but
yeah,
you're gonna have like a lighter amount of determinism where it just helps with like predictions and stuff, but there's still
completely.
authoritative states. Okay.
Yeah, and it's very easy to hack also a deterministic model, right?
Mm-hmm.
You in a deterministic model, you make the assumption that every participant is fair, uh, which is not the case
Yeah, you could
in
bust
FPS.
that
So.
pretty easily, probably, but at least I know. So for Age of Empires, I think that they send input, or a lot of the RTS games, they just send inputs.
Yep.
But if you purposefully were like a malicious player, you could break the flow pretty easily.
But not only you receive input, you send input, you also receive input.
Uh-huh.
And that's really the full deterministic model, the deterministic dream, because you are resimulating the world based on the other player input,
Wow.
right? Not on state. And that's pretty powerful because it's very small amount of data,
Very small.
but very dangerous too.
Yeah. And then everyone runs their own simulation. That's pretty crazy. That sounds like a nightmare to like make sure that there's not desyncs, but that sounds like a pretty fun thing to work on though, to be
Yeah,
honest.
yeah, completely.
Yeah, for my peer-to-peer game, it's like it's sort of like I made the one I made in Godot. It's like a party game sort of. It's an arena FPS party game that's just meant to be played with your friends. So I just
Mm-hmm.
let players send like their state to everybody because there's only like maximum 6 players, and like it's usually played with like people on Discord. They're, like their friend group is playing it or something. So it's like yeah, you can trust each other.
No, it's fine. Yeah, it's fine. Yeah.
Yeah. We sort of touched on this like a little bit earlier, but with just the way that stuff has shifted over time, have you seen like any other like huge changes in like philosophy as you've been working on like networked games and stuff? Just like the things that people value more and that they used to not as much
From the player or the developer
for the
perspective?
developer.
Mm, interesting. There is definitely more pressure from the audience.
Mm-hmm.
And so it's spread through, for example, we spoke about tick rate, so make this number bigger, kind of pressure. People will notice when their latency change too. So what I saw from the beginning of my career at Ubisoft, and now I work at Respawn, and I worked at Microsoft in the middle.
Mm-hmm.
And particularly this transition when I moved from Ubisoft to Microsoft, like 8 years ago, maybe, or 9 years ago, dedicated server became the norm. Before it was too expensive to run dedicated server, right? Because the cloud was not really there,
Mm-hmm.
and we were not really in the live service era either, so there was no like income stream to maintain a fleet of server. But then Microsoft arrived, and with the Xbox One principally, promised or over-promised a lot of cost saving, let's say, with dedicated server, which was not true at the beginning, but became true, right? And so we went from where most people were doing peer-to-peer, and peer-to-peer, it's like it has many shapes also. Full mesh when everyone is connected to each other, or listen server. For example, I worked on Gears of War, right? On Gears of War, or even Halo, old school. It's one of the client is the server, and everyone connect to this guy, right? And so that was a predominant model, let's say. And nowadays, everything has moved to cloud and to not even cloud, even bare metal still, but like to servers
Just
that run
dedicated,
somewhere.
authoritative servers.
And that changed a lot of things. Right? In the way you conceive your software, in the way before people were sharing the servers, for example, and it's less and less true right?
Mm-hmm.
You take your favorite game and you ask yourself, can I host the server for this game? And so the answer is certainly no, right? And so we move the control. Developer took back the control of those elements, mostly to entertain the live service component of their game. And also the iteration of updates. Right, to change everything before you will patch. People will have to download on some shady websites their patch, right? No,
Yeah.
it's all integrated and so on.
Everything
So from,
supports updates.
but even from a developer's perspective, right, you update your servers. Now that you control all the fleet of your server, you can upload your game in one go.
Mm-hmm.
And so we take pride and a lot of importance about all this what we call the pipeline, like build and release. You see how do you detect a bug in your game?
Mm-hmm.
How long does it take for one of your developer to fix it? How long does it take to deploy it to your player, right?
Mm-hmm.
And that's mostly the paradigm shift. And all of that happened, I think, because we moved from fully peer-to-peer, so only client,
Mm-hmm.
to server infrastructure somewhere. Yeah.
Yeah, that there's a whole different hurdle of problems, I guess, now.
But now now you have a lot of telemetry, like dashboards and so on, and you optimize your pipeline to be able to ship all the time, which was not true at all before, like 10 years ago.
Yeah. I know. So that also, like, I imagine with the increase in dedicated servers, there's a lot more like anti-cheat and security things you can do before too that you weren't able to do with the old peer-to-peer models.
Yeah, it depends. I mean, before it was easier because, for example, the Xbox 360 was a very secure console.
Mm-hmm.
Amazing security model. And so you could be confident at the time that people playing on console were very safe,
Mm.
right? But nowadays it's not true anymore mostly because of there is a lot of device that you can plug on your gamepad that will fudge your aim assist or your recoil component,
Yeah.
And it's because we entered what I would say before also all community were segregated by platform. And nowadays with crossplay, everyone is mixed together.
Mm-hmm.
So it completely changed the security view of your product.
Yeah, that I remember seeing an article or a blog post that Valve posted a long time ago about like the sort of arms race that there is with hackers. You
Yeah.
know, like you implement one thing and hackers figure out like another thing, and then
Particularly when you work
yeah.
on, for example, on Source, right? It's an engine that has been around, like, I don't know, for 10, 15 years.
Uh-huh.
Yeah, certainly 15 years. And so people, they know the memory layout of the classes. They know where to look for the position of a player. They know,
Mm-hmm.
every time you change something, they can tell, like doing the diff between binaries. Unreal Engine is the same, right? Like you take software like Cheat Engine, they are able to dump all the information, all the class, everywhere. Yeah.
Skip it for memory and stuff. I
Yeah.
imagine. Do you think having like players have access, if they have access to their own dedicated servers that they can run, does that open the door to like making cheating easier as well?
Uh, I I don't think so because if there is a flaw in your protocol, they will find it anyway from the client.
Uh-huh.
Uh, because it's enough of one guy in the world find it, and then it will spread,
That's all it
right?
takes.
So it's just a question of time. Like security by obscurity doesn't really work. It workish 2-3 years maybe, and then it will be broken. No, for me, the biggest concern about community-driven servers is data. There is two things. There is injection of malware into the client that you can do very easily, and there is stealing data, client data.
Mm-hmm.
That is pretty easy to do too. So that, yeah.
Oh, gotcha. So those are the number ones. That's interesting. Yeah, that makes sense now. Like that. Yeah, you can also like just sniff packets too and see what like backends are kind of doing and stuff in general too.
I mean, usually you use like DTLS, you use HTTPS. I mean, everything with a S to prevent those things, right?
Oh, okay. So you can sort of go against that. That makes sense. And then one more on the technical questions. I was looking at like I was reading some articles about how FPS games and like other ones are handling player interpolation, so other players.
Yeah.
And then I've seen Dead Reckoning come up a few times,
Mm-hmm.
but it seemed to me it was almost more common for people just to like dampen or interpolate in some way the between player packets or just some sort of
So it really depends of the game again.
mm-hmm,
The canonical example of that is you have a racing game, and it's just a straight line, and you have to go across the finish line. The finish line.
okay.
Um, both players start at the same time, but if you don't have dead reckoning or extrapolation, let's say,
Mm-hmm.
uh, both of those players will see themselves cross the finish line first,
Yeah.
right? You have two cars, you go at the same speed, but you will simulate yourself in the real time, and you will simulate the other guy in the past, in the packet you
Gotcha.
receive. So best case latency, right? Uh, and so if you want to avoid that, you need to have some kind of extrapolation,
Right.
and you will see yourself finish both at the same time, crossing the finish line.
Maybe for an FPS game, it's like it can be very sensitive if someone's about to peek a corner,
Oh
too.
yeah, in this case, you don't. In a competitive FPS, you never extrapolate. That's very simple.
Right. Because
Yeah,
like imagine someone's like they're about to pass a corner, but then they stop. If they didn't stop, then the dead reckoning, they'll predict that they passed that corner, and then the dead reckon, and then they'll be like, oh wait, no, they didn't. They'll
yeah,
snap back, right?
yeah. Usually, you never extrapolate on an FPS. You prefer to pay the cost. It's why I say it depends of the game. It depends
Depends on the
of your.
game. It's also a little bit more CPU intensive as well, right? Because you have to simulate more.
No, I don't know. I don't know about that. Yeah. So historically, racing game run on peer-to-peer full
Uh-huh.
mesh because they want the lowest latency.
Mm-hmm.
Because you have objects that travel very fast, like the cars potentially, and so you want to limit to a maximum the desync of state or the interpolation, extrapolation of states. So because if you don't have a server, you're directly connected together, right?
Mm-hmm.
You remove one hop in the networking, right? You can save twice
That's
bandwidth.
true. There's a round trip time from like on a dedicated server is client to server and then server to all the clients, whereas peer to peer is just like clients to each other.
Yeah. Plus you remove the server frame rate that's usually slower than the client,
Mm-hmm.
and so the saving is huge. Uh, but yeah, on a FPS, yeah, you particularly competitive, you never extrapolate. Of course, it's not really. It's only for dedicated server. Like in peer-to-peer, you always extrapolate usually
Mm-hmm.
because there is no really tick. There is no, uh, it makes no sense to. It's a bit like Unreal Engine actually when I think about it, because Unreal Engine is not using a snapshot system; it's object by object.
Mm-hmm.
So you don't have it's one of the problem of this engine, I would say, is that you don't have world consistency. When you join, when you play, you cannot be sure that all the world has been updated. You
Mm-hmm.
never know actually at which state you are.
Because
Uh,
each thing has its own.
Life is their
Yeah.
their own snapshot basically,
So you can't have just one snapshot. You need a snapshot for each single thing that's being replicated.
which is a very powerful concept because you can give priorities to things,
Mm-hmm.
right? So one thing can update at 120 hertz, one thing can update at 20 hertz, and so on.
That's
And
pretty
so
cool.
and that's used a lot in peer-to-peer to optimize bandwidth. Like for example, on Ghost Recon, the further away you are, the lower your tick rate is of the entities, right?
Cool. And that's supported kind of out of the box in Unreal.
And Unreal does that out of the box, yeah, yeah, yeah.
That's pretty cool.
But also, if you do a competitive FPS, there, because of this how can I say, this characteristic of the networking model, you never have guarantee that you have for a given time you have the full view of the world.
That's true. Imagine someone snipe, like they pass a corner with a sniper and then they zoom in and kill you. It's like, well, maybe they weren't considered important to the server, but they're kind of important because they're about to kill you with a sniper, you know?
So usually what people do is like they flag all the players as very high priority.
Yeah.
And so, but it kind of defeat a bit the system, because if you have too many players, that will limp at the top of the queue, but there is very little space for the rest. So yeah.
Yeah, that makes sense. Man, I guess my number one takeaway on this interview is it depends. For each the game, you have to like you have so many features that you have to decide like a subset of for your game for networking stuff.
Because networking is so close to gameplay, right?
Mm-hmm.
But at the end of the day, you are not like everyone can write a reliable UDP, whatever, right? Everyone can write a serialization thing. But what's the next step? The next step is about strategy of replication of behavior, like replicating player movement, replicating, I don't know what, right?
Mm-hmm.
Something moving. And those things are very gameplay driven. And therefore, as soon as you enter gameplay territory, you need to serve the design.
So you can't really go in with like an assumption of like how it should be done, what's correct and what's not correct. You just have to analyze the gameplay and go from there.
I mean, you can make assumption, but
Mm-hmm.
it will just box what you can do and how you can achieve it.
Okay.
Right? If you, for example, you want a GGPO model, a deterministic rollback model, you know your game will never have more than 4 or 6 players, certainly.
Mm-hmm.
Right? And that's a choice you made. You just need to be very self-conscious about those choices that you made and build your game on.
That makes sense. And then to get into some closing questions, so how'd you gave me a little bit of your background at the beginning. Did you sort of just like end up working on these multiplayer issues at Ubisoft because you were interested in them, and it just sort of like was like a natural transition?
Yeah, so my degree was already networking. I was in EE, but I was
okay.
in wireless communication. So I was already dealing with wireless protocol. I don't know, like Wi-Fi and ZigBee, or this kind of stuff, Bluetooth, like this kind of stuff. So I knew the basic, and then I grew from there. I did some backend programming, like so I started working on matchmaking and this kind of stuff. And then I pushed very hard to be able to do low-level networking. Usually it's very hard to start in networking because usually you have one guy, right, per game working on those problems.
Yeah.
And so it's a very look for skill, but also you don't need that many people. Yeah. And so I was lucky this way to be able to gain experience.
Yeah, that's pretty cool. That leads pretty nice in the next one. Is I'm also looking to break into game dev to do similar things, and I was wondering if you have any like tips on like the most important things to learn, or just like, any advice in general in that regard.
It's very hard, like, because in my experience, right, I had a very lucky start. I didn't add any indie game or didn't have any prototype like you're doing. But I think it's very good. I did hire people, very young people, that they had no resume and they just had a GitHub with some prototype of games. So that can work. But yeah, usually being able to reason about, like you spoke about corner picking problem, for example, like being aware. It's usually what you will be asked in interviews, right?
Mm-hmm.
You are aware of prediction, dead reckoning. What do they do? What are the pros? What are the cons? This kind of stuff. Yeah.
Everything has pros and cons for game dev. There's no.
Yeah, but you need to be. It's what I said, because it's design. So if one day we want to be able to assert, if a designer comes to you and asks you to do a feature, you have your toolbox in front of you and you're able to pick the good tool, right? And that's in an interview, that's what we were trying to understand, right? Are you guys that is going to resolve everything the same way? Do you have a breadth of cultures that, right?
Do you have options? Like, yeah, if you need to do, yeah, okay, that makes sense. If you need to do dead reckoning, can you do dead reckoning? If you don't need to, can you do something else?
Yeah.
That makes sense. Okay, this is a lot to think about, but I've really appreciated the interview and stuff because like I don't know, it's a little hard to find some from good sources on some of these
Yeah.
things. It's like I was trying
Yeah.
to research as much as I could, and like that tribes paper was actually like one of the best ones I found, for example, and it's
But
old.
it's very old and no one does it really this way anymore, right?
Yeah.
Uh, yeah, I think, yeah, it's with the advent of the Unreal Engine, particularly, like people don't think really about it. For Unreal Engine, people think about it mostly through the lens of performances, I think. How big can the scale, how much CPU can they save, trying to optimize this, but not really in terms of protocol or strategy, because it's so tied to the engine, right? Like this layer really, like the biggest problem, if one day you try to do a networking middleware for any engine, really the hard part, as I say, it's not serialization, it's not the transport. It's like this layer, how do you replicate game objects? How does this glue works, right? And that's really where the skill is needed, where most of the skill is needed.
Yeah, that makes sense. I did my one in Unity using their like low level transport protocol that they have.
Mm.
And that one seemed pretty flexible, but it seems like for a lot of engines they have like they're built around a sort of design at least a little bit.
Yeah, I would look, if you want good references, I would look at Photon, for example,
Photon, okay.
which is a middleware. But the middleware that has been around forever, but it's a very good one.
Yeah, I've heard a lot about it. So looking into how it works or looking into using it.
The first thing I would look for is the patterns they expose. So I know they have a deterministic engine. I know they have the snapshot model, certainly. And so you look at the stack basically they give you, and you kind of know where do they export, right? What do they sell, and what people use. And I think that's when people try to shop for, like they have a game, right? And they try to shop for a networking thing, and they will look at those provider, and they will take the ones that fit their need.
Yeah.
And so if you read their documentation, you will learn a ton, like how to design a good API for this use case, and how to,
because that one supports a bunch of different types of things, right?
Yeah, everything.
That's a
Nearly.
good
They've been around for so long that, yeah.
I'll have to read through them and it'll be cool for even just trying to make my own implementation of things that they have.
Yeah, for sure. It's the best advice I can give you to learn. You look at the API and you try to redo.
Awesome.
Because the hardest to figure it out, I think, when you start from zero, is to what are the API to my customer, and your customer are usually gameplay programmer. And so what goods looks like, you cannot really make it up on your own, I would say, without, yeah. And so you look at those commercial products, what they do for you, and you try to emulate.
I think, yeah, that's good. I'm gonna have to read through that later because I've had like some little bits I've been stuck on occasionally for this project, like the input buffering and stuff, and like I was stuck on that for a little bit, and then some other things as well, like delta packets, making delta packets.
Yep.
Some things, but yeah, no, I really appreciate this interview. It's been super interesting. I'm glad I have it all recorded, hopefully twice.
Hopefully twice. All right.
Thanks, Samy.
Thank you. Take care.
Take care.